Hi, everybody. Wanted to spend some time talking about this regression table that we have in the textbook. This regression table is from a paper by economist Nathan Nunn, and it was part of his PhD dissertation from Harvard that he then published. And this paper is pretty straightforward. The table that we'll look at, we'll focus on this table, looks at the relationship between slave exports and income. And as he notes in the table, the dependent variable is the log of real per capita GDP in 2000, the log of y. So that's the outcome variable is the log of GDP per capita in the year 2000. We see here that there are 52 observations. So the unit of observation is the country, and there's 52 of them. These are the countries in Africa. So 52 countries, and we observed their log GDP in 2000. Some countries are richer than other countries. And we're asking whether there was, the regression table is asking whether there was a long-term relationship between these countries' experience, the people in these countries, the history in these countries, experience of the slave trade, the in the 1600 through 1850 period, and their GDP today. So, did something that happened long ago in the past leave a long shadow or mark into the present? So, for his simple specification, the first specification, the only explanatory variable is the log of slave exports per unit area of the country. So obviously, a bigger country is going to have more slave exports than a smaller country. So we have a kind of per unit area of slave exports, and it's the log. Where does the data on the slave exports come from? Well, historians over the last 50 years prior to this dissertation had been collating all of the ship manifests from records and customs manifests. And so there are pretty good records of this slave economy. The Atlantic slave trade, probably the most recorded, but there was also a Red Sea, Near East slave trade with slaves going into the Arabian Peninsula and Iran and Iraq. And these were mostly slaves, maybe captured in Sudan or Ethiopia that were being transported there. And then there was also an Indian Ocean slave trade with slaves on the eastern coast of Africa, what's sometimes called the Swahili coast, and them being taken across the Indian Ocean. So there were the Red Sea coast and the Indian Ocean probably considerably smaller than the Atlantic slave trade, which was by most estimates about 10 to 15 million slaves were transported across the ocean. So the others were probably smaller in magnitude. And that's the records that are available for the 200 years of the slave trade. So, so we have exports per area, and we see that it's a log specification. The outcome variable is a log, and the explanatory variable is the natural log. So we have interpret the coefficient as the percent change in per capita GDP for a 1% change in slaves per area. So the effect then is that a 1% change in slaves per area is associated with a 0.112, right? So we'll just round it to be a 0.1% change in GDP. Alternatively, we might say that a 50% change in slave exports, so increasing the slave exports by 50%, is associated with a 5% reduction. So, right? We multiply zero point 0.1 times 50, and that's zero point 0.5. So that's 5, I'm sorry. So a 5% reduction in per capita GDP in the year 2000. So 5% per capita GDP, suppose per capita GDP were $1,000, a 5% reduction would be $50 per person. That's per capita GDP. $50 per person times a lot of people, 1 billion people, maybe 800 million people living in the countries. This is back in, you know, GDP in 2000, so I don't recall what exactly the population was, is let's say it's $50 billion a year. And if we're saying this is the effect for 1 year, it's similar, could be that that's the similar effect every year. So every year, GDP per capita, on average, per total GDP then, not per capita, is $50 billion lower. So this over a decade or 2 decades, this adds up to not a trivial sum as the lingering, long-term, persistent effect of the slave trade. So that's our first specification and our interpretation of the coefficient. So this coefficient on log exports of the slaves over the time period stays roughly the same magnitude and same statistical significance, doesn't change very much across the different specifications. I should have noted, by the way, that there is one specification. The first specification isn't quite a single variable regression. There are dummy variables for whether the place was colonized by the British or the French. So these are called the colonizer fixed effects. Essentially means there's a dummy variable in there, two dummy variables for whether it was colonized by the British, and another dummy variable whether it was colonized by the French. There, some places were colonized by the Portuguese, a few, Mozambique, Angola, and then there were a few that were never colonized, Liberia, well, difficult to treat how they were colonized. Liberia became an independent country, sort of under the tutelage of the United States, um, at some point in the 1800s. Ethiopia was never really colonized. So we have a variety of regions, and there's some variation in who the colonial powers were. Uh, as we move on to other specifications, we have some dummy variables, we have some log variables, we have some percent variables, we have a dummy variable whether the legal origin was France, a dummy variable for whether it's North Africa, the log of gold production, the log of oil production. So, for example, we see the log of oil production is statistically significant for every 1% increase in production per population per person. GDP is going up by 0.07%. So it's a relatively small coefficient. The oil production is concentrated in just a few countries, but it's so if you spread it out, it would be large, but it's a small magnitude because only a few countries are affected by the oil production, but they're made a lot wealthier in terms of per capita GDP by oil production. Um, Gold and diamond production, we see not attaining anywhere near that magnitude of effect, and not statistically significant. The other significant coefficient we see here is the log of the coastline per area of the country. So some countries have a tiny coastline, some countries have a large coastline relative to their area. This is going back to Adam Smith, that the wealth of nations determined by the size of the market. Being on a coast and having a large coastline makes it more likely that you're doing international trade. You also have more fishing, so another economic opportunity. And we can see that that's tends to make countries wealthier. Not hugely wealthier, but about the same order of magnitude as the slave exports, right? 0.09. So a 1% increase in your coastline is associated with a 0.1% increase in your GDP per capita. Um, so I think that's pretty much it for interpretation. Let's look down here at the notes. Always good to look at the notes. OLS estimates of one are reported. The dependent variable is the natural log of real per capita GDP. Slave export variable is the natural log of the total number of slaves exported from each country between 1400 and 1900 in the four slave trades normalized by land area. The colonizer fixed effects are indicator variables for the identity of the colonizer at the time of independence. Coefficient, so standard boilerplate. Good. So I hope you'll spend some time thinking about this regression table and being. This is a very typical regression table, a good example of a straightforward ordinary least squares regression table with log specifications, dummy variables, percent specifications. So pretty interesting regression table.